Hi guys, Mr. Hescox Physical Science here, trying to get you guys some practice with atoms and your periodic table. So I thought we would start with this practicing atoms. These are some worksheets from an old textbook, but they're better practice than some of the ones we have today. While we're doing this today, you're going to want your periodic table out. If you don't have that out, make sure you get it out right now. This first section here is really just practice with looking at different types of compounds. The formula for a compound indicates the elements that make up the compound and the number of atoms of each element in the compound. So these are different types of ions. Alright, so I thought we'd get started on some of these so I can show you some examples. So the first one there, aspirin, you have C9H8O4. So if you go to your periodic table, C is carbon, H right here, hydrogen, and O right there, oxygen. So then you just count the atoms. So carbon has nine carbons, 8 hydrogens, 4 oxygens for that one. If we jump back, I want to show you one of these more difficult ones. So this TNT is actually what is in dynamite. So the equation, or the formula, I guess, is C7H5 parentheses NO2 3. Now that's one of those polyatomic ions. You have to distribute this, but unlike math class, you distribute backwards. So C is carbon, 7. Here's 5 hydrogens. So when you don't see a number beside this, N is nitrogen, by the way. When you don't see a number there, you assume that that is a 1. 3 times 1 is 3. Then you take 3 times 2, so the O for oxygen, 3 times 2 is 6. And that's how you would do that one there. On this next page of the packets, you'll see a section called Drawing Atoms. So you'll still need your periodic table for this one, but you have to know that when you're drawing atoms, the number of protons equals the number of electrons. And then to get the number of neutrons, you take the atomic mass minus the atomic number, and that will tell you how many neutrons there are. So let's start with a real simple one here. We'll come over here. Here's helium. Helium has an atomic number of 2. It has 2 neutrons. It tells you that now. So when we draw that out, proton, proton, you can just put positives in here for protons. Neutrons are neutral, so when we draw those in, we're going to put zeros because they're not positive nor negative. The number of protons, or the atomic number, is also the same as the number of electrons. So we draw in our 2 negatively charged electrons, and there you have helium. I'm going to go ahead and jump ahead, and we're going to do neon, Ne, on your periodic table, is right here. So it has 10 protons, It has an atomic mass of 20, so you take 20 minus the 10, and it has 10 neutrons. So there's two ways to draw this. I get it's kind of hard to draw that many little particles. Most are going to draw one solid nucleus, and you're going to put 10 positive protons, 10 neutral neutrons. Now here's where your electrons come into it. The first shell only holds 2. The second electron shell will hold 8. So you draw one electron shell, you put in 2 electrons. If it has 10 positives, it has to have 10 negatives, so you need 8 more. This second shell will now get 8 more electrons drawn into it. So that when you have 10 negatives, 10 positives, the atom is neutral. Alright, so now that we've drawn some atoms and we talked about the names of the different elements, we're going to look at this atomic structure. So they give you a element, the symbol, the atomic number in this case. The atomic number is always the number of protons. You get the mass number, so that is the number of protons and neutrons. And then you have to figure out the protons, neutrons, and electrons. So the atomic number equals the protons. If you take the mass minus the atomic number, you'll get the neutrons. The atomic number in this case also equals the electrons. So helium, right here, has an atomic number of 2. That means it has 2 protons. It has 4, so you take 4 minus 2, it'll have, it'll have 2 neutrons, and because it has 2 protons, it has to have 2 electrons. So if we move a little more forward, we'll go ahead and jump down and do one more here. I'm going to pick one that's a little bit more difficult. Let's say we do sodium. So sodium is Na. Sodium has an atomic number of 11. So if its atomic number is 11, that means it has 11 positive protons. The mass number is going to be the number of neutrons and the number of electrons. So it's 11 plus 12, which is 23. You know that it has the 11 neutrons. It has 12 neutrons. In fact, it tells you that right there. So if it has 11 positives, it's going to have 11 electrons that are negative. And you guys will be filling this in as you go. One of the last things that we talked about in section 1 is the isotopes versus the same element. Basically, to be the same element, you have the exact same number of protons with a different number. So number 1, element D has 6 protons, 7 neutrons. Element F has 7 protons, 7 neutrons. Because they have different numbers of protons, for number 1, when you have these different numbers of protons, these are different elements. They're not the same thing. For number 2, element J has 27 protons, 32 neutrons. Element L has 27 protons, 33 neutrons. Okay, so you have different numbers of neutrons, but the same number of protons. These ones are isotopes. We'll do one more. Number 3. Number 3 says element X has 17 protons, 18 neutrons. Element Y has 18 protons, 17 neutrons. Okay, well, right here it tells you as long as you have different numbers of protons, these are different elements. Alright guys, so that should give you a clue as to do how each of these sections here, you're going to be working on them in class or at home. I know there's a lot of people who are home right now with all of the quarantining and things going on. I hope this helps. If you need me, email me at bmh@blwd.k12.pa.us. Until next time, I'm Mr. Hescox. See you later.